Hey everybody, this is Chris Brandt. Last week, Sandesh Patel and I headed out to New York City to attend the HPC plus AI Wall Street High Performance Computing Conference, and I am here to break it down for you, so stay tuned. Before we get started, I just wanted to ask you to take a moment and subscribe if you haven't already. We have broken 100,000 views now, so the channel is growing fast and your support helps tremendously. So like I mentioned, Sandesh and I went to the HPC plus AI Wall Street conference, where friend of the show Ryan Quick was a featured speaker. There were a bunch of sessions focusing on everything from quantum computing and neuromorphic computing to artificial intelligence and big data. The show was run by Tabor Communications, that is the publisher of HPC Wire, Datanami, and EnterpriseAI, to name a few. Now, this is a show with a limited audience, so it's interesting to see how small a community it is right now. And most of the people know each other in this space, and there's a lot of back and forth with people. Much of the discussion focuses on fairly cutting edge and exotic tech, so I thought it was a ton of fun. And there was even a great session on the ethics surrounding AI. A lot of the vendors in the space sponsored the event and were there to talk about what they have for HPC. And I was able to chat with a few of them, and I wanted to share some of those interviews with you. But let me have them tell it to you in their own words. So tell me a little bit about what RunAI is and what you guys do.
So hi everyone. We help companies to get the most out of their GPUs and compute resources. We provide a job scheduler for Kubernetes in a cloud-native architecture. We also have identified that many of the workloads are not actually consuming their entire compute. So we have developed a way to partition GPUs on the fly. So you can run more jobs on the same infrastructure. Better return on investment, but also better performance, making sure that your productions are getting into market, but also in an economic sense.
So how would you guys say you differentiate in the market? Like what makes your scheduler particularly unique?
I think we are the only job scheduler that runs within the Kubernetes architecture, but also we provide a way to optimize the compute. So it's not only a job scheduler, but a holistic compute platform that can support the entire AI lifecycle, from the development, training, but also for the deployment and the inferencing of the product, but also the ability to provision subsets of GPUs and compute resources. We can help organizations manage multiple clusters, both on-prem and in the cloud. And actually, many organizations use us as the bridge to manage between their on-prem and the cloud and have a hybrid architecture with our platform.
And so how long have you guys been around?
Founded in 2018, post-C round. We have offices in Israel and here in New York. 100 or so employees, serving mostly enterprises. But interestingly enough, you would imagine that enterprises would be the most advanced on their AI journey, but it's not exactly right. We are working also with some very cool startups that are way out there in the field and doing some really cool stuff with AI. So it's not a matter of the maturity of the company, but the maturity of their AI initiative and their AI journey.
Yeah. And so who are your investors?
So the major ones are Insight Partners and Tiger Global.
It's a good batch there.
Yeah, exactly.
Well, I'm hearing good things about you guys, so it's exciting.
Thank you so much. I appreciate that.
All right, thanks. Next up, we got a chance to catch up with Memberge. You may remember them from episode number 44, where we talked with Memberge founder and CEO Charles Pham. So here's Memberge.
So Memberge has been around for the last 5 years. For the last 2 years, we've had our flagship product, Memory Machine, available. And so Memory Machine basically helps to tier memory, and that's going to be really key for people that are going to get into the CXL technology in the future. And we're excited about that. We also have a cloud offering that we call Spot On, and so that we can save customers quite a bit of money by utilizing Spot On, whether it be in AWS or Azure or in Google. We have a solution for all three of those.
What do you see happening with the CXL market these days?
So the CXL market is all really starting to come together. All of the announcements, if you will, have come from the consortium. So the specifications for 1.1 and 2.0 and 3.0 are now available. And I think what you're seeing are a lot of the suppliers, if you will, are building to those specifications. And we're doing likewise. So we're basically taking what we know for Memory Machine and also with our product Memory Viewer. And we're going to be morphing those into more of a pool manager to support the CXL ecosystem, so that you'll be able to share memory and have memory pools across disparate systems within that ecosystem.
So I hear you guys are moving on, beyond like the Optane sort of architecture. What's
I'm sorry?
The Optane
architecture?
architecture?
Optane was great for us, basically to get our start and to cut our teeth and to learn how to, basically tier memory. And we did, quite a few deployments with Optane. It's now been announced as end of life, but there's still, capabilities for people to deploy it. There's still plenty of supply out in the marketplace. So for those customers that want to continue in that direction and use our product for that, we certainly can support them. But we're also at the same time working towards, like I said, the CXL infrastructure that's, forthcoming, because we think that that's going to be pretty large across, the whole marketplace. The Intel space was, one portion of it, but now this is going to be more open to all of the, chip vendors to play in as well.
Yeah, no, it's been an interesting journey to watch you guys grow. I think we first ran into Charles like maybe 3 years ago,
right,
at a Lightspeed Venture conference, and and he was just this wild mad scientist.
Yeah.
And,
so it's been a fast growth pace for us, but it's been a fun ride, and like I said, we're ramping up and gearing up for what's coming with CXL, and the market seems pretty excited about it, and we're getting a lot of good response from that.
Sounds great, man. Thanks so much.
Thank you.
And last, here is friend of the show, Ryan Quick, who not only hosted a couple of sessions, but was there to help promote Data Vortex, a new networking stack designed around extremely high performance. All right, so Ryan, good to see you back.
Thanks, nice to be here.
So you're helping explain Data Vortex. Could you tell me a little bit about what it is and what it does?
Yeah, so Data Vortex, they're from Austin, and they have a proprietary IP for developing a wholly new type of network altogether. So Coke Reed, their founder, he was a Princeton mathematician who solved a problem that had been around since the 1930s, a really popular problem. He solved it in the 1970s, and then developed IP based on this particle flow dynamics, which is what the original IP is about, to create a whole new type of packet flow. And so what they have done now, fast forward until now, they have a new type of network altogether. They call it the Data Vortex. When you visualize it, it looks kind of like a vortex. It's not actually a circle, but it looks that way. And it's got some unique features over other networks. First of all, it's not a crossbar network at all. It doesn't have latency hops. And all packets and everything are delivered synchronously, and they're guaranteed. So you have guaranteed message send, guaranteed delivery. If a packet enters a network, it's going to come out. It's optimized for fine-grained networking, so generally smaller packets. You can move large data across it, but it gets broken into small packets, and packets cannot collide, and they cannot be partitioned, right? So it's really good for things like FFT, for graph traversal and stuff like that. And they do have, they've actually built systems, and they're deployed at national labs and other parts of the government we can't really talk about. and what they're doing now is taking that technology to its next generation, where they have an IP block implementation in RTL, and they're now moving that into FPGA with dev kits. They're working with AMD Xilinx right now to do that, and they currently have Tiger Graph running on top of the network, and they're showing between a 200 and 1200x performance increase simply by using the network. They haven't modified Tiger Graph at all. And the work that I've done with them recently is to take distributed consensus algorithms, most particularly Raft, which is the consensus algorithm that underlies etcd, which is popular with Kubernetes. It underlies a lot of blockchain implementations and in other places. So we've taken that code, and we have replaced the transport layer with Data Vortex. and demonstrated that by using the capabilities of the network, you can actually eliminate 4 of the 7 problems that distributed consensus has to solve. So, distributed consensus says, I don't trust the network that I'm working with. I don't trust the person that's sending the message. I don't trust that the message will get there. I don't trust that the message, once received, is actually going to be processed. And I can't trust that a reply is going to come back to me. Now, how do I handle getting agreement? Well, those first 4 things can all be solved in the network itself with Data Vortex. You can trust the network any packet that comes on it will get delivered. You can control whether or not someone sent it or someone delivered it. You know always who got the messages. And in the last case, you can actually deliver the messages to all participants at exactly the same moment by clock cycle. So on this clock cycle, everyone received the message. That means there's no possibility for getting timing out of whack, no out of order messages, no drop messages. And also, because the network only uses known participants, it has to be configured every time you start it. There's no way to partition the network, which is a big problem for consensus networks, where you get split brain when you take a node out of whack. So none of those things can happen. And so what we said was, well, if we can take these four of 7 problems off the table, what can you do with consensus? And it opens up a lot of things. Now, we haven't gone into what those things are. We haven't worked on that part of the problem. We've simply demonstrated that you can do it. So now it's time to dream.
So just this network technology, is it more for like a cluster, or is it like what sort of distance is this?
So it can be implemented over any distance. So right now, what we're primarily focusing on is interlinking chip to chip, accelerator to accelerator, memory to memory. So they have a global addressable memory space. In the test for Tiger Graph, for example, there's 16 gig of memory per unit. All 256 gig are addressable by any accelerator. And so it's something like what you would see as a NVLink with NVIDIA. But it can connect any component. So in that respect, it seems a lot like what CXL is advertising for Intel. But it's wholly different. It doesn't run TCP. It's its own thing.
So how do you do guaranteed delivery with no latency?
So I'm not the math guy. So it's difficult for me to explain what happens. But basically, if you think of the network as one long line, instead of having increments where you're joining a switch or crossing a boundary and things like that, all the distance of between 2 entities on the network is exactly the same all the time. So any packet that enters the network must traverse the network to get to its destination, and no other packets can follow that particular path until it's delivered. They have a command segment that's running alongside the data segment. And so basically there's an announcement that says packet entering, packet leaves, acknowledged, resets what they call a barrier, and then the next packets flow. And then of course they can actually do that in parallel, so it's not one at a time, but you get the idea.
Interesting. This sounds like the kind of technology that's probably going to require a deeper dive.
Yeah, especially if you get into the math, it's really interesting and difficult. So, like me, I'm not the math guy, but I have seen it. I have tested it. We did a previous test a few years ago where we took RabbitMQ and we put RabbitMQ over top. And our very first test, we shattered the world record of messages per second, and we didn't actually, we integrated it as 2 separate standalone programs. So it was like Rabbit handed off to a program through a socket, and then we moved it and took it back again. And the previous world record at that time was Google had done a test with 32 nodes, and they had crossed 250,000 messages per second boundary. We ran on 2 nodes, and we crossed 2 million messages per second.
Wow.
Yeah.
That's. Yeah. I mean, I think that's exciting stuff, because the network stack needs to be revisited.
Oh,
desperately.
Yeah. I don't think we think of it as an Ethernet or InfiniBand killer. It's not really designed for that. It is designed for that fine-grained messaging. But what people don't realize is that you can have all the bandwidth that you want, but most networks, Ethernet, Wi-Fi, InfiniBand, to be sure, are they're optimized for large data movement. Like move a lot of data, big packets, fill them up, send them. This is not. So what happens on an Ethernet network is if you're trying to send lots of small data, it still takes all the space of that large packet, and then you run over the packets per second that a particular switch can handle. So you might only be using, 20 gigabits of 100 gigabit length, and that's all you can get out of the switch. In this particular case, it's dead linear, and so they've measured over 20 billion packets per second on the current implementation. So it's crazy different. But it's not to say that it's the only network out there. What we think is, you don't want to stay the same all the time, right? And for me especially, I believe in generally specialized systems. And so in places where you need that kind of communication to interlink different components in either a cluster or inside a specialized system, it makes great sense.
Yeah, very cool stuff.
Thanks.
Thanks. Overall, this was a small but great show that will only be growing over the years. And if you are looking into high-performance computing, I suggest you check the next one out. As always, thanks for watching. I would love to hear from you in the comments. Please click the subscribe button, and I will see you in the next one.